Hi, and welcome to Allen High School's discussion of pre-AP chemistry. We're talking about bonding, and I guess my little cat got in the way to remind us that we were talking about cations and anions. We're going to finish up right now with the properties of ionic compounds, which is important because structure determines function. That was my cat again, kiddos. Knocking calculators off the table. Rascally little things. All right, so ionic compounds, because they have such a strong positive, negative, electrostatic. You should learn that word, electrostatic. It's a good vocab word. Electrostatic attraction. Most of them are solids at room temperature because they have such very high melting points. A notable exception would be mercury, which is a liquid at room temperature. I would show you that, but they kind of don't like us to buy mercury around here. So, in order to melt an ionic substance, you actually have to break. It takes energy to break bonds. So if you think of this, if you break, it takes. If you form, it frees energy. So it takes energy to break, and we're breaking an ion-ion attraction, and it takes a lot of energy to do so. All right, they break when they are cleaved. They're very brittle by and large, often. Ionics are. You can think of, salts. And like if you go from rock salt, you could just take a hammer and crush it, and you would have close to table salt, right? And the reason is this. They have this alternating plus, minus, minus, plus, minus. Now, when you break or cleave, you end up shifting layers. And I'm being a little simplistic, but I want to get you the idea. Now, if I shift this layer, what's going to happen is that negative is going to come near that negative, and this positive will come near that positive, and they'll push each other apart and they'll fracture. Okay? Many, but not all, are soluble in water. What happens is that ions are attracted to partial charges. We're going to delve into this a little bit more later on, but let me just tell you that there's a partial, not a full positive, a partial. And it's like you start drawing a figure 8 and stop a little early. It has a partial positive and partial negative end. Water does. And the negative ions are attracted to the partial positive, and positive ions are attracted to the partial negative. And some of them, if these are strong enough, will dissolve. Ionic compounds are not conductive as solids. In order for a substance to conduct, we need some sort of pathway for electron movement. And mobile ions are one such pathway, not the only such pathway, but one such pathway. But the problem is that as solids, there are no mobile ions. They're not mobile, they are rigid. And so they do not conduct as solids. Now, they do conduct in their molten or melted liquid state, because the ions become mobile, and that provides that pathway for electron movement. And they also conduct when they are in aqueous. You want to learn that word. That's a very important word, aqueous, dissolved in water. Okay? Now, that's it for now. We're going to move on to covalence in the next video. So until then, this is signing off.